Welcome to the mutation testing presentation of Wim Spaargade and Rick Proost. Before we start, we give a short overview of our presentation. First, we'll give a brief introduction to mutation testing and PyTest. After that, the projects we decide to use will be stated and motivated. Then the result of the PyTest and a chosen project is laid out. And lastly, our work will be compared with the work of Ino Zvezda. Mutation testing is used for two main purposes: to design new software tests and evaluate the quality of existing software tests. Mutation testing involves modifying a program in small ways. Each mutated version is called a mutant, and tests detect and reject mutants by causing the behavior of the original version to differ from the mutant. This is called killing the mutant. Test suites are measured by the percentage of mutants that they kill. In our results, these will be stated as mutation coverage. New tests can be designed to kill additional mutants. Mutants are based on well-defined mutation operators that either mimic typical programming errors, such as using the wrong operator or variable names, or force the creation of valuable tests, such as dividing each expression by 0. The purpose is to help the tester develop effective tests or locate weaknesses in the test data used for the program or in sections of the code that are seldom or never accessed during execution. Mutation testing is a form of white box testing, which means that it tests the inner working of an application. PyTest is a mutation test framework for Java. We will use this framework to analyze free open source Java projects and Java projects we develop ourselves. In the slide, the selected projects are shown. The first one is our context project from year 2 of the bachelor. It was written in Java, and we were curious about how it would stand against mutation testing. The second project is an open source project called OKHTTP. It is an HTTP client that's efficient by default. We choose this since we know from experience that it's hard to test internet connections with unit tests in general. We only analyzed the URL connection project inside the OKHTTP project, since we expected a large mutation line coverage difference for this project. The third project we choose is a Spring Boot framework. We thought the Spring Boot framework was interesting since it's a widely used framework for Java to create standalone applications, and it's well tested. And lastly, we chose FastJSON because it's a popular JSON parser for Java and probably used by many other big Java projects. This is probably also the reason it has so many tests, and now we can see if these tests are really productive. Our bachelor project is, took for example 1 hour to run all mutation tests, since it reads very large Excel files. We also had problems with FastJSON project where tests took very long or got stuck. It also was not very clear where and why these tests got stuck. Because of this, we took for the open source project packages which we thought were interesting to run mutation tests on. This could have been avoided when we were able to set some sort of timeout on how long PyTest could spend on mutating a test. The results for our own context project are quite good. The biggest difference here can be seen in graph package between the line coverage and mutation coverage. Taking a look at the test, we can see that we initialize a few things but only assert one thing at the end of the test. This differs a lot from our other tests in other packages, and it explains the low mutation coverage for the graph package. For the OKHTTP project, we only analyzed a single project called URL connection, since we were not able to get the whole OKHTTP project up and running. In the overall coverage report, we can see that the internal package is not tested at all, which results as expected in 0% mutation coverage. We will dig deeper into the internal HUC package, since this contains the connection implementations of the URL connection package. The internal HUC package looks as follows. We can see that the mutation coverage is almost half of the line coverage, which indicates a lot of inefficient tests. We checked out the output stream request body.java class file. For this 71% coverage, it only has 32% mutation coverage. We can see that in the slide that a lot of functions let mutations survive even though they are tested, which indicates the tests which are written for this project are not very effective. The next project is a Spring Boot project. We only mutated 4 packages because the mutations took too long due to the size of the Spring Boot packages. We can see 77% of the mutation was covered, which is the highest coverage percentage we came across. The results for the Spring Boot application can be seen in the coverage report. Admin and NSI and bind packages are tested quite well, since the mutation coverage is 75% and higher. One interesting result we found for the Spring Boot PyTest is that the NSI package has more mutation coverage with less line coverage. We found that it is due to the fact that some classes inside the NSI package are enumeration implementations, which contain a lot of variable declarations which are not covered by mutation tests. Since the builder package has low mutation coverage, we took a deeper look into this package. The coverage report of the package itself can be seen in the slide. The context application initializer and listener have a lot of uncovered negated if statements and few if statements with just 5 negated conditionals. For fastJSON, we tested the parser part. In total, there were too many tests and PyTest kept running. We found the parser part the most interesting, and in the overview we can see that the lowest mutation coverage can be found in the serializer package. In the serializer package, a serializer factory was found that had almost 100% line coverage but 0% mutation coverage. Almost everything in this class is initializing, and this low percentage mutation coverage tells us these methods are not mocked. These methods are run by a lot of tests and therefore line coverage is high, but the methods themselves are not specifically tested. This could be a problem in the future if weird faults occur. You can never know for certain everything is initialized how it should be. Another funny thing in fastJSON is the switch statement, where the developer probably did not want to assert every return. In the first paper, coverage is not strongly correlated with test suite effectiveness. There is a lot of emphasis on the fact that mutation testing can reveal real faults. We found that it can help you detect real problems or parts that are not tested properly. However, there are also some trivial parts that mutation tests will create problems that are not there. 2 examples of that are in the slide. The first one is one that really identifies a problem. The computation data undo method can be removed without any test failing. This means that the check is forgotten, and it could be so that the computation undo is not even working properly. It is definitely worth checking out after you see this. The other example is one that only takes up your time. The method creates a hash map and counts the same code, so ups the counter for every code found every time. The mutator then turns the +1 into a -1 and no tests are failing. The counting is trivial, however, and this would only cause exhaustive testing for no particular reason. After running PyTest for many projects, we can conclude that mutation testing makes it very easy to see which tests are not effective and can be improved. This also means finding real problems in your code. Another advantage of mutation testing is that it's really fast because of the automated way it mutates the code. This means exhaustive testing will actually exhaustively testing while actually saving a lot of time by not doing the exhaustive testing yourself. We found 3 disadvantages of mutation testing, however. The first one is that mutation tests can generate mutations which are not real problems for the program but might appear as surviving mutants. The second disadvantage is that with large inputs can be problematic for PyTest since they can take very long run or appear to freeze, but it is more a PyTest problem than mutation testing. The last disadvantage is that to be able to use mutation testing, you first need tests to mutate. In a way, it is trivial that if you don't write good tests, the mutation testing will just tell you you don't test effectively.